Okay, this video is going to show how to determine the equation of a quadratic function given the vertex point and some other point. Okay, so in vertex form we have y equal to a times x minus h squared plus k, where h and k are the vertex. Okay, if you're given the vertex, v equal to hk, then you can just sub that in. Then all you need to do to find a is have another point. Okay, so if you have another point, then you can sub that in for x and y, and then solve for a. So if you know h and k and some other point, so that you can sub in for x and y, because the equation needs to be satisfied for that point, then the only unknown left is a. So you sub in hk, sub in xy from the point, solve for a. Okay, so a quick example of this would be if you've been given the vertex 2, 5 and some point 3, 2. So these are 2 points on the curve, but the vertex is convenient because we can sub it right into this form. So we sub the h in right there and the k in there. And then you can sub in the point P. There's x and y for x and y. Okay, so the y coordinate is 2, so I'm going to put it in where the y is. The x coordinate is 3, I'm going to put it in where the x is. Okay, now the only unknown here is a, so you can simplify this and solve for a. 3 minus 2 is 1. 1 squared is 1. So you're just going to have 1a here. That's what you've got. And then the 2 here and the 5 here. Subtract 5 from both sides and you get a equal to negative 3. So now you have a, h, and k, and you can just sub them in. So a is negative 3, h was 2. Okay, so the h was 2 from there, and k was 5 from the vertex. Okay, a couple more examples of this. So say you're given the point, or the vertex 2, 1, and the point 0, 5. Well, now you take the 2, 1, that's your h and k, and notice that 0, 5, well, it's actually the y-intercept. So I could have said just the y-intercept is 5, and you know that another point is 0, 5. Okay, so 0, 5 is the 5 is the y-intercept. So you sub in the h and the k, so the 2 in for x, and the 1 in for k, that's 2 in for h, 1 in for k, and then you sub in the point 0, 1, or 0, 5. Okay, so 0 goes in for the x, which just makes that 0 minus 2, and it's negative 2 squared, and the 5 in for the y. Negative 2 squared is 4, so you get 4a plus 1 on this side. Subtract 1 from both sides, so bring that over there, you get a 4 over there, so 4 equals 4a. Divide by 4 on both sides, you get a equal to 1. So now you have the quadratic function y equals 1, so 1 is the a right here, but we don't put a 1 there, right? X minus 2 squared, because 2 was h, plus 1, which is k. Next one, another example. So the vertex is negative 3, 2, so there's h and k, and the point 0, 0. So that's an easier one to sub in. So y equals a times x plus 3, remember to change the sign there, plus 2. Okay. Sub in the point 0, 0, so 0 for x, 0 for y, and you get 0 equals a times 3 squared plus 2. And now you've got 0 equals 9a, because 3 squared is 9, plus 2. Bring the 2 over, negative 2, and a equals negative 2 divided by 9. Now you can sub that into the vertex form. Y equals negative 2 over 9, which is a, x plus 3 squared plus 2. Okay, one more. two more actually. Okay, so we've got the vertex for this one is 2, 0, and the point is 5, 3. Okay, so when you sub the 2 in for the h right here and the 0 in for the k, well then you don't need the plus anything here. This plus 0 can just go away, and now you just have a perfect square. Not only is it in vertex form, it's in factored form too. Okay, so y equals a x minus 2 squared, and you can sub in the point 5, 3, 5 for x, 3 for y, the 5 in there, 3 in there, and then you can solve for a. So 5 minus 2 is 3, 3 squared is 9. So a equals 3 over 9, which is 1 over 3. Simplifies, always simplify your fractions. And sub that in to the equation that we have for a, and we've got y equals 1/3 x minus 2 all squared. Okay, last example here. 0, 4 is a vertex. The point is -3, -1. Okay, sub in the vertex. So h is 0, k is 4. So the part in the brackets here is just x now. Okay, so we get this form, y equals ax squared plus 4. Now we can sub in the point, -3, -1. So -3 for x, -1 there. And now we get this for our answer. So when we sub the numbers in, we can evaluate -3 squared is 9. Bring the 4 over to this side, you get -5. And then divide both sides by 9, you get a equal to -5 over 9, and you just sub that back into the original, which is up here. And you got the equation of the quadratic as y equals -5 over 9 x squared plus 4. And that's it for this one for vertex form.